In this video, we will discuss about minimized maximum of products distributed to any store. You are given an integer n indicating there are n retail stores. There are m product types of varying amounts which are given as zero indexed integer array quantities where quantities of I represents the number of products of the ith product type. You need to distribute all products to the retail stores following these rules. A store can only be given at most one product type but can be given any amount of it. After distribution, each store will have been given some number of products, possibly zero. Let X represent the maximum number of products given to any store. You want X to be as small as possible. That is, you want to minimize the maximum number of products that are given to any store. Return the minimum possible X. So what they are saying is that in the input, we are given an integer n denoting the number of retail stores, and we are given an integer array quantity which denotes the quantity of different product types. So here we are given 6 stores and these are the quantities of the different products. So let's suppose this is product P1 whose quantity is 11. This is product P2 whose quantity is 6. Now what we want to do is that we need to distribute all these quantities or all these products to our stores. Now what are the conditions for it? The conditions are that we need to distribute the entire quantity. All of these products with their entire quantity should be distributed to the stores, and to one store. To one store, we can distribute only one type of product. Meaning, if I am giving some quantity of product P1 to some store S1, then I cannot distribute any other product to this particular store. It can have only one product type. And you can give any number of quantity. So here product P1 is having the quantity as 11. So either you can give all of these 11s to a single store, or 0 or 5 or any number, right? So any quantity you can give. Right. So now after you assign all these quantities to the different stores, then whatever is the maximum quantity that you have assigned to any of the store, you need to minimize it and return it as your answer. So we will understand what they are asking. So first let's understand through the example so you will be able to understand the question. So here we are having 6 stores, right? So let me represent them with S1, S2, S3, S4, S5 and S6. Right. So now we need to distribute all of these products, right? And the conditions I have already told you. So one of the possible ways is that for the product 1, I give the entire quantity which is 11 to this store, right? So all the 11 I gave to this store, and for next product, I again gave all the quantity to this store, right? In that case, others will get 0, right? Then other possibility is that again I have given all the 11 quantity to S1, but for the second product I have given, let's suppose, 2 to this, 2 to this, 2 to this, and for rest it will be 0, 0, right? Other possibility is that for this 11 I give only 4 to S1 and then 4 to S2. Then how many are remaining? 3 are remaining, right? So 3 I gave it to this, and for this second product type I gave 3 to this store and 3 to this store. So this will have 0 now, right? And the other combination is that for this 11, I can give 3 to S1, 3 to S2, 3 to S3, and the remaining 2 to S4. So 11 is completed. And then for 6, I can give 3 to S5 and 3 to S6, right? So like this, there can be multiple combinations, right? So now what you need to do is that you see in this combination, what is the maximum quantity that you have assigned to any store? 11, right? Then in this case also it is 11. In this case it is 4, and in this case it is 3, right? So what you want to do is that whatever is this maximum number, that you need to minimize. So in all of these combinations, you have to find out what is the maximum quantity that you have assigned, and then out of these, whichever is the minimum, that has to be your answer, right? So in this case, 3 is the minimum. So ideally, this is the best possible combination. So our answer will be 3 for this particular case, right? So now, how are we going to approach this problem? So now, if I ask you that, are you getting a hint of, like, can we identify a particular range of the quantity that can be assigned to a store? So meaning if I am asking you that what is the minimum quantity that you can assign to any store? 0, right? 0 is the minimum quantity that you can assign to any store. And what is the maximum quantity that you can assign to any store? So what will be the maximum quantity? It will be 11. Now, why 11? Because see, we cannot do the sum of all these quantities, because to one store we can assign only one product type, right? So now out of all these quantities, whichever is the largest quantity, the max quantity, that is the maximum number of quantity that you can assign to a store, right? So can I say that my answer will always lie within this range, right? My minimized maximum will always lie within this range, right? So now that I have got the range, I just need to find out the most optimal value between this range, right? So now how are you going to do that? So let's suppose I am saying that I can take any number from this range, right? So let's suppose I took 4. If I took 4, then that means that the maximum quantity that I can assign to any of the store is 4, right? I cannot go above this. So if you are assigning the maximum quantity as 4, then in that case, how would you do? So if I remove all this, so in that case, for this 11, you can assign 4 to S1, 4 to S2, and then 3 will remain. So these 3 can be assigned to S3, right? And then for 6, 3 can be assigned to S4, 3 can be assigned to S5, and 0 to S6, right? So now you see that when I have taken my maximum quantity as 4, I am able to distribute all the quantities to my given number of stores, right? So then that means for this I am able to distribute. So for the numbers which are smaller than 4, which is 0, 1, 2, 3, for them also it might be possible to distribute, right? See, for 4 we were able to distribute. So then that means for 5, 6, 7, for all of these we will be able to distribute, right? But we need to minimize our answer. So there is no logic of going beyond 4, right? So we know that for 4 we are able to distribute. So then for 0, 1, 2, 3, the numbers which are smaller than 4, for them also it might be possible to distribute, right? So then we can check any other value within the range of 0 to 3, right? Or 0 to 4. 4 you have already checked anyhow. So now within the remaining numbers you can check, right? So let's suppose now I took 2, right? Now I took 2. Now if you assign the maximum quantity as 2, then at that time what will happen? For this 11, what you will do? 2 you will assign to S1, 2 to S2, 2 to S3, 2 to S4, 2 to S5, and now 1 is remaining, so 1 to S6. But now for assigning this 6, you are left with no stores. So in this particular case, we were not able to distribute all the quantity, the entire quantity to the given stores, right? Then that means this cannot be my answer, and the numbers which are smaller than this, which is 0 and 1, so for them also I cannot distribute, right? So there is no point in checking for the numbers below 2, right? But again, for the numbers which are greater than 2, it might be possible that we can distribute, right? So then you can check for 3, and then you can check for 4, but then you will see that your range was within 4 only. You have already checked for 4, right? So when you will check for 3, you will be able to distribute the quantities, and then your range will also finish. So at that point, you can say that 3 is my optimal answer, right? So what we are doing is that we can check for all the numbers within this range, and for whichever numbers which are able to distribute the entire quantity, we can check that which is the minimum number out of them, right? And that minimum number will be our answer, right? But in this case, you will be checking for this entire range, right? So all the numbers. So from here 0 to 11 you will be checking. Now let's suppose this number is very large. Then in that case you would be taking too much of time to identify, right? So now think of something through which we can make it faster. So if you see that we have the range from 0 to 11, then that means 0, 1, 2, 3, 4, and so on till 11, right? We just need to find out a number from this range which satisfies our condition, right? And we also know that in which case what we want to do, that whenever I am able to distribute with a particular number, then that means I might be able to distribute with the numbers which are smaller than this. So then that means I have to shift my range towards the left, right? And whenever I am not able to distribute, then in that case I should shift towards the right. So basically I am decreasing my range every time. So are we not applying binary search here? Can we apply binary search here? We can, right? So what we can simply do is that you have got your minimum, you have got your maximum, you can find out the mid element, right? You can find out the mid element, which will be max plus min, or you can denote them by left and right also, or start and end, right? So left plus right divided by 2. With this, you will be able to get the mid, right? So then you can check that for this number, are we able to distribute or not? If we are able to distribute, right? If it is possible to distribute, then in that case, what you can do is that you will shift your range towards the left, right? Then that means you will change your right to mid, right? Because as I said, for 4 it was working. So we will change our range to 0 to 4, right? So then that means if it is possible to distribute for this mid, then we can make our right equals to mid, right? And if it is not possible, then that means we need to shift towards right. So in that case, when it is not possible, then you can do left equals to mid plus 1, right? So for the current mid, anyways, we are not able to distribute. So there is no point of taking it into consideration into the next range, right? So that's why in the left, we are doing mid plus 1, right? And you can do this entire process until your left and right becomes equal, because as soon as they will be equal, you will be at the smallest quantity that can be assigned to any store, right? So once you get out of this loop, you can return any of them. You can return either left or either right, because both of them will be containing the same number. So basically you have to do this entire thing while your left is less than right, this entire thing, right? And your left and right will be 0 and 11. So see, there is no point of taking 0 here. Why? Because in the question it is given to us that we are assigning the all the quantities to our stores, right? Then that means 11 and 6 I have to assign anyhow, right? But when we are checking for 0, at that time what we will be doing, we will be assigning 0 to all of these, right? Which is not possible. We have to distribute these, right? So minimum, instead of 0, you can take it as 1, right? You can take it as 1 instead of 0, right? So our range will then become 1 to the maximum quantity out of these quantities, right? This will be our range, left and right, right? Now, how are you going to identify this possible thing that for a particular mid, are we able to distribute the quantity or not? So that is also very simple. So let's suppose my mid is 3, right? Then in that case, how you will distribute? So you know that you need to distribute 11 quantity, right? So you will do 11 by 3. Now this will give you 3 point something, right? Then that means 3 stores I for sure need for giving 3 quantity. And whatever is the remaining decimal place, for that also I need 1 store, right? So what I'm saying is that it give me 3 point something, then that means to these 3 stores, I will assign 3 quantity, right? So here I assign 3, here I assign 3, here I assign 3. Now this total is 9, right? But still we are left with 2. That's why we got a decimal number here. So for this remaining decimal, we need 1 more store. For the remaining 2 quantity, we need 1 more store to assign, right? So what we can do is that while applying this formula, we can do seal off. We can do seal off 11 by 3. Then in that case, it will give you 4. In that case, it will give you the exact number of stores that you need for distributing these many quantities with the maximum quantity as 3, right? So basically, you can do seal of whatever is your quantity divided by the max quantity, right? So what you can do is that for every quantity, you can apply this formula, right? So it will give you some number of stores. So you can maintain a variable stores, right? And in this variable stores, whatever is the value that you are getting out of this formula, that you can add inside stores. Then if at any point this stores exceeds this limit n, then that means we cannot distribute it, right? So you can there itself say that it is not possible for this particular mid, right? And if for all the quantities the store never exceeded the limit of n, then that means we can distribute it. It is possible, right? So I hope you got the problem. We will code it out now. So first of all, we will define our range. So our left will be 1 and right will be the maximum quantity, right? So for finding out maximum quantity, we can use a built-in function max element, in which we will give quantities dot begin comma quantities dot end, right? So this is a C++ built-in function which will return you whatever is the maximum element present in quantities vector. Okay, so now that we have got the range, we need to apply binary search, right? So we will apply a loop while our left is less than right? Now inside this, we need to calculate the mid. So mid will be equals to left plus right divided by 2, right? Now that you have got the mid, you need to check that are you able to distribute or not with this mid, right? So for that, let's create a function here which will return us a boolean value, right? Let's name it can distribute, right? Now what all it will receive? It will receive the max quantity that we are assigning, right? Then it will receive the quantities vector, right? And then it has to receive the maximum number of stores that we have, the number of stores that we are given in the input, right? So here what we'll do is that we will pass this mid and we will check what we are getting. So we'll check that if can distribute is possible. Inside this, what you will pass, what is the maximum quantity? Mid, right? Quantities vector will be passed as is and the number of stores are n, right? So we will check this. Now if it is true, then that means we can shift our range towards the left. So now our right will be equals to mid, right? Otherwise we will move towards right. So now left will become mid plus 1. And at the end you can return any of them, left or right. So we are returning left here. Now in this can distribute, how you will check? So you need to keep the count of stores that you are distributing the products to, right? So for that, let's create a variable current stores. Initially it will be 0, right? Then you need to iterate inside your quantities vector, right? So it will give you quantities dot size and I plus plus, right? Now inside this we will do current stores plus equals to seal of. So now our variables are integers, so we will need to typecast it to double for applying seal. So we'll write double here, and then we will do whatever is our quantities of I divided by the max quantity, right? And then if at any point our current stores exceeds the number of stores given to us, then in that case we can return false here itself, right? Otherwise at the end out of the loop we can return true. So let's run this now. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please subscribe our channel.